Hello children, today we will discuss properties of inverse trigonometric functions. In this section, we shall prove some important properties of inverse trigonometric functions. It may be mentioned here that these results are valid within the principal value branches of the corresponding inverse trigonometric functions and wherever they are defined. Let us recall that if y equals to sine inverse x, then x equals to sine y, and if x equals to sine y, then y equals to sine inverse x. This is equivalent to sine of sine inverse x equals to x and sine inverse of sine x, which is also equals to x. First set of formula is sine inverse 1 upon x equals to cosec inverse x. Cos inverse 1 upon x equals to sec inverse x. Tan inverse 1 upon x equals to cot inverse x. Then second, the most important formula, sine inverse x plus cos inverse x equals to pi by 2. Let us derive this formula. So let sine inverse x equals to y. Now we can write this as x equals to sine y. Now in place of sine y we can write cos 90 minus theta, that is pi by 2 minus y. So cos will shift here. It is x equals to cos pi by 2 minus y. Now cos will shift here. We can write cos inverse x equals to pi by 2 minus y. So cos inverse x equals to pi by 2 minus, in place of y we can write sine inverse x. Now sine inverse x will shift here left hand side. So it is sine inverse x plus cos inverse x equals to pi by 2. So this formula we have proved. Now tan inverse x plus cot inverse x is equals to pi by 2. Cosec inverse x plus sec inverse x equals to pi by 2. We can prove these two formula also similarly as we have done the proving of first formula. Now third set of formula is, which is the most important formula. Tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. This should be the angle. Similarly, tan inverse x minus tan inverse y equals to tan inverse x minus y upon 1 plus xy. Now fourth set of formula is, these all are related to 2 tan inverse x. So 2 tan inverse x can be interchanged in sin inverse 2x upon 1 plus x square, cos inverse 1 minus x square upon 1 plus x square, and tan inverse 2x upon 1 minus x square. Now exercise 2.2, question number 1 to 4. Prove the following. First question is, we have to prove that 3 sin inverse x equals to sin inverse 3x minus 4x cube. So we will start from right hand side. Sin inverse 3x minus 4x cube. Now if we assume that x equals to sin theta, then we can say that sin inverse x equals to theta. Now putting the value of x here, it will be sin inverse 3 sin theta minus 4 sin cube theta. Now you have studied in class 11 that 3 sin theta minus 4 sin cube theta is the formula of sin 3 theta. So sin inverse and sin will eliminate. Answer will be 3 theta. Now in place of theta we can write sin inverse x. So which is 3 sin inverse x equals to left hand side. Now question number 4. Here you can see 2 tan inverse 1 by 2 plus tan inverse 1 by 7. If we convert this 2 tan inverse 1 by 2 into tan inverse x, then we can apply tan inverse x plus tan inverse y. So 2 tan inverse 1 by 2 can be written as tan inverse 2x. 2x means 2 into 1 by 2 upon 1 minus x square. 1 minus 1 by 4. And this tan inverse 1 by 7 will remain as it is. So after simplifying this, we will get tan inverse, it will be 1 upon 3 upon 4, which is equals to tan inverse 4 by 3 plus tan inverse 1 upon 7. Now we can apply the identity tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus x into y. After solving it, you will get tan inverse 31 upon 70, which is right hand side. Question number 5 to question number 10. Write the following functions in the simplest form. So question number 5. Now we can assume let x equals to tan theta, which means tan inverse x equals to theta. If we put here, so it will be tan inverse under root 1 plus tan square theta, and 1 plus tan square theta will be sec square theta. and square root of sec square theta is sec theta minus 1 upon tan theta. Now we convert sec theta into 1 upon cos theta and tan theta sin theta upon cos theta. If we simplify it after taking the LCM, we will get tan inverse 1 minus cos theta upon sin theta. As I told you earlier in the beginning of this session, wherever you will find 1 and cos theta together, first thing you have to do, you have to eliminate 1. So half angle formula we can apply. 1 will remain as it is. In place of cos theta, formula is 1 minus 2 sin square theta by 2. But here minus sign is, so 1 plus 2 sin square theta by 2, and sin theta 2 sin theta by 2 cos theta by 2. 1 will eliminate, 2 will eliminate, sin theta by 2, sin theta by 2 cancel. So it will be tan inverse sin theta by 2 upon cos theta by 2, which is tan theta by 2. Now tan inverse tan eliminate, theta by 2, and in place of theta we will write tan inverse x. So simplest form is half tan inverse x. Question number 8. Again we have to write it in simplest form. So there are 4 terms in the bracket. If we divide each term by cos x, so we will get tan inverse 1 minus sin x upon cos x is tan x upon 1 plus tan x. Tan inverse, in place of 1 we can write tan pi by 4. Tan 45 is 1. So tan pi by 4 minus tan x upon 1 plus, we can write tan x as 1 into tan x. So in place of 1 again tan pi by 4 into tan x. Now tan inverse, this is the formula of tan A minus tan B upon 1 plus tan A into tan B, which is equals to tan A minus B. So tan pi by 4 minus x. Tan inverse tan eliminate. So pi by 4 minus x is the simplest form of given question. Question number 9. Tan inverse x upon under root a square minus x square. So here let x equals to a sin theta. So which implies that theta will be equals to sin inverse x upon a. Now tan inverse in place of x, a sin theta upon under root a square minus a square sin square theta. So tan inverse numerator as it is a sin theta. If we take a square common, it will be 1 minus sin square theta. and 1 minus sine square theta is cos square theta. So tan inverse A sine theta, after taking square root, A cos square theta, square root of cos square theta is cos theta. A cancel, so it will be tan inverse sine theta upon cos theta is tan theta, which is equals to theta. And what is theta? Sine inverse x upon A is the simplest form of given question. So similarly, you can do exercise 2.2, question number 1 to question number 10. Thank you.